students, today I am going to discuss about Pauli's exclusion principle. Pauli's exclusion principle. Okay, this principle is given by Austrian physicist Wolfgang Ernst Pauli in 1925. Okay, this principle is given by Austrian physicist Wolfgang Ernst Pauli in 1925. He awarded Nobel Prize. He awarded Nobel Prize in 1945, right? For his discovery of exclusion principle. For his discovery of exclusion principle. This principle states that no two electrons in atom can have same set of four quantum numbers, that is n, l, m and s. In other words, no two electrons in atom can have same set of all four quantum numbers. I am repeating. Each electron in an atom is associated with four quantum numbers. That is, each electron in an atom is associated with four quantum numbers, that is n, l, m and s. Okay. For one electron, the value of n, l, m and s are same. That is unique. N is called principal one number, l is called algebraic one number, m is called magnitude one number and s is called spin one number. Okay, I am repeating. For one electron, the value of n, l, m and s are same. That is unique. For two electrons, the value of n, l, m are same, but the value of s is different. That is, for example, an orbital contains two electrons. For first electron, s equal to plus half and second electron minus half. That is, one is clockwise and other is anti-clockwise. This rule states that no two electrons in an atom can have same values of all four quantum numbers. Now, explaining by taking some examples. I take helium, that is number 2, 1s2. Okay, n equal to here 1, l equal to 0, m equal to 0 and s equal to plus half or minus half. That means this 1s orbital contains two electrons. Okay, for this two electrons, the value of n, l, m are same, but the value of s is different. Here n equal to 1, l equal to 0 means l means 0 to n minus 1. You know that m is equal to minus l, 0 to plus l. For s sub cell, the value of l 0. L 0 means m 0. For this two electron, one is plus half, other is minus half. For this two electron, the value of n, l, m are same, but the value of s is different. That means no two electrons in atom can have same values of all four quantum numbers. Now we take another example. Nitrogen, habit number 7. Okay, that is 1s2, 2s2, 2px1, 2py1, 2pz1. We can write in this manner. Okay, this is 1s orbital, 2s orbital, 2px1 orbital, 2py1 orbital and 2pz1 orbital. Now we calculate the value of n, L, M and S. Right? Here the value of n equal to 1. For S subset value of L 0. L0 means M0. For these two electron, one is clockwise, other is anti-clockwise, that is S equal to plus half, other is minus half. We have seen that for these two electron, the value of L, M are same, but S is different. One is positive half, other is negative half. Similarly, for 2s orbital, n equal to 2, L 0, M also 0, S equal to plus half and minus half. Right? Similarly, for 2p orbitals, n equal to 2, 2, 2, L equal to 1, 1, 1, M equal to plus 1, minus 1, 0, that is principal axis, and spin equal to plus half, plus half, plus half. You see here, for these three electrons, the value of n, L and S are same, but the value of M different. Here, the value of n, L, M same, S different. For these two electrons, the value of n, L, M same, S different. If you compare two orbitals, 1s and 2s orbital, the value of n are different. Here n1, here n2, but the value of L, M, S are same. To compare 2s and 2p x orbital, the value of n 2, but the value of n different, and also the value of m different. Similarly, compare 2px and 2p orbital, the value of n same. The value of n same, but the value of m different. One plus 1, another minus 1. That means the orientation of orbital different, but the value of s remains same. We clear that for this example, no two orbitals in an atom, no two orbitals in atom can have the same value of no two orbitals in atom can have the same value of the three quantum numbers. That is n, L, M. Okay. For two orbitals, the value of n, L, M are not same. Okay. No two orbitals in atom can have the same values of the three quantum numbers, that is n, L, M. Okay. This principle also tells about to calculate number of electrons in cell, subcell and orbital. Now explain. For example, that is cell, that is n value, that is L value, that is M value, that is S value. That is number of electrons on subcell. Okay, number of electrons, that is cell, that is n value, that is L value, that is M value, that is S value, that is number of electrons on subcell, number of electrons on cell, that is main cell. Okay, first consider K cell. The value of n for K cell 1, the value of L becomes 0. You know that L is equal to 0 to n minus 1, right? m is equal to minus L0 plus L. L0 means N0. That means L subcell, that is S subcell contains one orbital whose value is 0. This orbital contains two electrons, that is one is clockwise and is anti-clockwise, right? For that, the number of electrons subcell, that is 2, and number of electrons in cell also 2. Similarly, L cell value of n equal to 2, L value becomes 0 and 1. By applying L equal to 0 to n minus 1 rule. Similarly, the value of m becomes what? 0, that is minus 1, 0 and plus 1, because m equal to minus L, 0 plus L. Similarly, that is S, that is P. That means the P subcell contains 3 orbitals, Px, Px, Py, Py, Pz, and S cell contains 1 orbital. Here the 2 electrons present, that is plus half and minus half. Here 2 electrons present, plus half and minus half. Here also plus half and minus half. Here also plus half and minus half. That means here the S subcell contains 2 electrons and P cell contains 6 electrons. 2, 2, 2. That is 6. That means the L cell contains 8 electrons. Similarly, for M cell, value of n is equal to 3 KL. The value of L becomes 0, 1 and 2. 0, 1, 2. Similarly, you can calculate, that is S, that is P, that is D. Here S equals 0 and contains 2 electrons, plus half and minus half spin value. Minus 1, 0, plus 1. Here minus 2, minus 1, 0, plus 1 and plus 2. That is plus half and minus half, plus half, minus half, plus half, minus half. Here plus half, minus half, plus half, minus half. Here also plus half, minus half. Here also plus half and minus half. This means the S subcell contains 2 electrons and P cell contains 6 electrons. 2, 2, 2. That is 6. And D cell contains 10 electrons. 2, 2, 2, 2, and also plus half and minus half. That means 10 electrons. That means the AX cell contains 18 electrons. Here for this orbital 2 electrons, for this orbital 2 electrons, for this orbital 2 electrons, for this orbital 2 electron, for this orbital 2 electron, for this orbital 2 electron, for this 2 electron, for this also 2 electron. We get 18 electrons. That means AM cell contains 18 electrons, right? Similarly, for N cell, we contains N cell value of N equal to 4. L becomes 0, 1, 2 and 3. Okay, the value of M becomes the S, that is P, that is D, that is F. The value of M becomes 0. Here minus 1, 0, plus 1. Here minus 2, minus 1, 0, plus 1, plus 2. Here minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Right? Here the S value, spin value, that is 2 electrons contains plus half and minus half. That means number of electrons subcell 2. Here P sub contains 3 orbitals, plus half and minus half, plus half, minus half, plus half and minus half. That is 6 kilograms. Here also plus half, minus half, plus half, minus half, plus half, minus half, plus half, minus half, plus half and minus half. That is 10 kilograms. 2, 2, 2, 2, 2. Similarly, for F substance contains, each orbital contains 2 kilograms. That is plus half, minus half, 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 plus half and minus half. That means F substance contains 7 orbitals. Each orbital contains 2 kilograms. That is 14 kilograms. Number of kilograms cell, you count all the kilograms. 13 plus 10, 24 plus 6, 30 plus 2, 32. That means N cell contains maximum 36 kilograms. Okay. That means this one number helps to calculate number of kilograms in main and cell, subcell and orbital. Now draw the conclusion from the principle. Conclusion. Number 1. Maximum number of kilograms in a main cell equal to 2n square. That means maximum number of kilograms in a main cell equal to 2n square. N is called the principal number. Number 2. Maximum number of subcells in a main cell equal to n value. Maximum number of subcells in a main cell equal to n value. Number of kilograms in a subcell equal to 4l plus 2 rule. L is called algebraic number. Number 4. Number of orbitals in a main cell equal to n square. I am repeating. This principle helps to calculate maximum number of kilograms in a main cell by according to n square rule. Number of subcells in a main cell equal to n value. Number of kilograms in a subcell equal to 4l plus 2. Number of orbitals in a cell equal to n square. Number 5. An orbital maximum contains 2 kilograms. Maximum contains 2 kilograms with opposite spin. Now discuss about the electron configuration of copper and chromium. Okay, chromium, that is 24, argon 4s234. This is the expected EC. Argon 4s1 3d5. This is the actual EC. EC means electron configuration. Copper 29, that is argon 4s2 3d9. Expected EC. Argon 4s1 3d10. This is the actual EC. Okay. Expected, actual, expected, actual. This is the actual concentration of chromium and copper. This can be explained on the basis of half filled and fully filled electron configuration. The half filled and fully filled configuration are more stable due to the symmetrical distribution of electrons and large exchange of energy. 3d4 configuration, 3d4. 1, 2, 3, 4, d4. This is d5 configuration, that is 1 2 3 4 5. D 9. D 9 configuration. D 10. D10 configuration. Okay, D4, D5, D9, D10. You see, the D4 is less than half field. D5 is exactly half field. Half field means each orbital in the same subcell contain one electron each. That is half field. This is symmetrical. That means all orbitals contain one electron. This is unsymmetrical. Is stable due to symmetry. This is less stable due to unsymmetry. Due to symmetry and stable, they have low energy, they have high energy. Similarly, D9 and D10, D10 is symmetrical because each orbital contains two electrons with opposite spins. It is symmetrical and fully filled. Fully filled means each orbital contains exactly two electrons with opposite spins. Less than half fields. The symmetrical is unsymmetrical, stable, less energy, high energy. Therefore, according to the symmetry concept, D5 and D10 configuration more stable than D4 and D9 configurations due to symmetrical distribution electrons in orbitals. Now discuss large exchange of energy. Exchange of energy. What is exchange? Exchange nothing but shifting of electrons in the orbitals. Shifting of electrons from one orbital to another. Setting up electrons from one orbital to another within the same subcell. Okay, shifting up electrons from one orbital to another orbital. Shifting up electrons from one orbital to another orbital within the same subcell is called exchange. That means exchange of electrons. Okay. Now discuss D4 and D5 configuration. D4 configuration. D4. 1, 2, 3, 4. First electron, second electron, third and fourth. Okay. The first electron, we choose first electron. 1, 2, 3, 4. First electron. The first electron exchange how many ways? 3 ways. This first electron can exchange between second, third and fourth electron in 3 ways. Similarly, the second electron can exchange in 2 ways. First electron exchange between second, third and fourth electron in 3 ways, and the second electron exchange between third and fourth electron in 2 ways. Similarly, the third electron can exchange only between fourth electron, that is 1 wedge. And fourth electron can exchange, no exchange between themselves, 0. That is total number of exchange in D4 configuration, that is 3 plus 2 plus 1, that is 6 ways. Okay. Exchange means exchange of electrons, that is shifting of electrons from one orbital to other in the same subshell. That is, first electron can exchange in 3 ways, and second electron can exchange in 2 ways, and third electron exchange in 1 way. No exchange expressed in case of fourth electron. So that the total number of exchange in D4 configuration equal to 6 ways. 6 ways. Similarly, in D5 configuration 1, 2, 3, 4, 5. First electron, second electron, third, fourth, 5. The first electron can exchange. In how many ways? 4 ways. First electron exchange in 4 ways, and the second electron can exchange in how many ways? 3 ways, and the third electron can exchange in how many ways? 2 ways. Similarly, the fourth electron can exchange how many ways? 1 way. And no exchange expressed in case of fifth electron. So that total number of exchange in case of D5 configuration equal to 4 plus 3 plus 2 plus 1, that is 10 ways. Okay, 10 ways. In D4 configuration, the number of exchange expressed in 6 ways, and in case of D5 configuration, the number of exchange expressed in 10 ways. So that the exchange energy more in case of D5 configuration than D4 configuration. Similarly, if you consider D9 and D10 configuration, D9 and D10 configuration, the number of exchange expressed in D9, 10 plus 6. Upspin 5 electrons, downspin 4 electrons, 10 plus 4, 16 ways. Similarly, for D10 configuration, number of exchange expressed 10 plus 10, that is 20. Similarly, D4 we can get D4 6 ways, and D5 that is 10 ways. To compare, those orbitals having large exchange energy is more stable. D10 have more exchange energy than D9, so that D10 becomes more stable than D9, and D5 have more exchange energy than D4, so that D5 is more stable than D4, so that they have filled and fully filled configuration more stable due to symmetrical distribution electrons between orbitals of the same subshell and large exchange energy. It's all about the issue of copper and chromium. Thank you a lot.